So we are using the Discord channel, Experiment Week, to coordinate, to ask questions. Let's keep it live. Let's joke around, post memes, talk about life, talk about what you're building. Don't be shy. Let's make that channel be very active. There's a team formation sheet. If you haven't yet added your team there, please do. It helps us keep track of everything. Of course, you can add it if you don't have a team yet. Then you should go to Experiment Week on Discord, try to find a team, try to find an idea, and then add it to the team formation sheet. We have the blog posts, all this info. It was released on the announcement channel. I'll post it on the Experiment Week channel again. And you have the project submission form, which is going to be more important towards the end of the week. So just a couple of general thoughts. Have fun. It is about fun. Don't overwork yourself. Share what you're doing. So share with your peers on Discord. If you have a X, a Twitter account, Facebook, Instagram, LinkedIn, just talk about what you're doing to us, to your friends. Help one another. This is supposed to be a team building, a community building exercise. And also, very important, think about what we're doing from a UX perspective as well. So we have a team, a unit here that is a specialist in acquiring feedback from developers, the dev advocacy unit, and they're always looking for feedback. And the core unit is also always looking for feedback. So take this sense that you're looking at what we're building from a builder's perspective, from a user perspective, and think about feedback and how to improve the experience in general. Just an addendum, we are lucky to have our Experiment Week at the same time as On-Chain Summer by Base. It's also the second edition that they're launching. It's actually a quite similar initiative as the Experiment Week, but it lasts for an entire month, right? Or actually an entire summer. So it starts on June 3, so just last week, and it will go until August. So if you, there's a lot of information. I posted the link on the blog post as well. They have over $2 million in prizes. And you build on Cartesi, submit it to Base, and it's going to be fun. We do have some apps that were already tested in Base, so the deployment to Base is quite similar. For those that don't know, Base is just a OP chain, so it follows the OP stack, and it's actually the chain that is run by the Coinbase folks, and they're doing great strides there. It's actually a very fun community. All right, so that was it from me. I'll invite now the very kind folks from Espresso to talk a little bit about what they're doing. So I'll add Alicia here. Let me just figure out how to do that. Oh, okay, someone did it for me. Welcome, Alicia. Thank you for accepting this invitation. You're muted. I'll give you the mic.
Hi.
Hello.
Awesome. Do you guys hear me well?
Perfect, yeah.
Okay, amazing. I will start sharing my screen now as well. Does it give you, right now it's giving me the ability to share my Discord screen, but not Chrome. Okay, one sec, I see it.
Nice, I can see it.
Amazing. Well, firstly, I think this is such a good idea to have a week off just to hack around and experiment with things. I love hackathons, so let's go builders. And I'm very excited. Yeah, for sure. Yeah, we should have like a cross partnership experiment week. I think that's a great idea. Awesome. So I am a software engineer at Espresso Systems. I've been there for 6 months now. My name is Alicia Huggins, and I've been in the blockchain space as an engineer since 2018. So I'll just walk you through the future of rollups with Espresso. We imagine that they will be more interoperable, performant, and sovereign. So currently we have over 30 EVM layer 2s or rollups. with over 30 billion TVL locked across them and over 30 bridges. So that means we can also say that there are over 30 sequences. So first, let's talk about the job of a sequencer. I'm sure many of you know it, but I'll still just go through it because I just want to run through the basics. So the sequencer is responsible for selecting which transactions will be included in the rollup block, as well as their order. So sequencers is a term that you probably would have been hearing about in the last 1 year, 2 years, but before layer 2s, it wasn't a term we would talk about. We will more talk about the validators. As a result, I just want to walk through the transaction life cycle on layer 1. And for the rest of this presentation, whenever I say layer 1, I'm referring to Ethereum. So the user submits their transactions and it goes into a transaction pool or mempool. And then the validator that is selected to order for the next block will then propose the next block by selecting transactions from this mempool. And when it selects transactions from this mempool, it would normally choose it based on revenue it can earn. So for example, the highest gas fees and priority fees. And then finally, other validators within the network would try to verify that this block of transactions is valid based on the protocol rules, as well as, just checking to see the transactions make sense. And then once they agree, we can say the blockchain state is final. So finality is something that we are aiming for on chain, regardless if it's a layer 1, layer 2, or layer 3 chain, we all want to get to the point of it being final. So if we were to compare the transaction lifecycle on layer 2 versus layer 1, we see that the validators are the ones that are responsible for selecting and ordering transactions on layer 1, so Ethereum. But on layer 2 chains, the sequencers are responsible for selecting and ordering those transactions. And when it selects those transactions, it still has a bit more work to do. So it will submit it to the block on layer 2. And then a batch of transactions is also submitted to layer 1 to be validated. So the state has to be validated by layer 1 before this block can be considered final on L2. So therefore, L2 finality depends on L1 finality. But if we think about finality of Ethereum, we know that it takes about 12 to 15 minutes for a transaction or for a block to be considered final. However, when we are interacting with the blockchain, that's not the experience we have. When we're interacting with Ethereum, we see that it's final within about 2 to 3 minutes and even less time on a layer 2. So how exactly do we get these fast speeds and how do we trust them? So this is where I bring to you the difference between finality and pre-confirmations. Just out of curiosity, how many of you guys have heard about pre-confirmations before? I don't know if there's a way for you to raise your hand. Or I don't know how Discord calls work. Or maybe just say in the chat, yes, if you've heard of it before or no. And pre-confirmations is something that everyone interacts with it, even though we don't really talk about it. So a block is considered final when we know for sure that that block and all preceding blocks will not be changed, therefore considered immutable. So when you submit a transaction and you check it on MetaMask, sometimes you see the status as unfinalized and eventually you'll see it as finalized. However, when we interact with the blockchain and MetaMask, we normally, get a confirmation within 2 to 3 minutes. And that's because MetaMask is giving you something called a pre-confirmation. So it shows you that the transaction is confirmed once the first confirmation is received. So in the case of Ethereum, once the validator that proposed that new block to the blockchain submitted it, MetaMask would then see that block and then they would say, okay, we can see the status of your transaction and this is what we're showing you within MetaMask, and you see the same on Etherscan as well. But it actually takes 12 to 15 minutes for it to actually be final and immutable. So this pre-confirmation is the same thing that we use on layer 2s. When the sequencer now submits these transactions to the layer 2 chain, to the layer 2 blockchain, again, we are depending on this pre-confirmation, which in this case comes from a sequencer. But the difference between a sequencer and a validator is that the validators are part of a consensus network, but within a rollup, most rollups are running centralized sequences. So rollups today run isolated chains, and we know this experience because when we have to interact with a rollup chain, we have to bridge our assets from Ethereum onto that chain or from one rollup to another. So they have a separate transaction mempool, a separate sequencer, etc. So there are some drawbacks, which means we lose some interoperability. So we are accustomed with the DeFi Legos that we are used to on Ethereum. But when we are bridging our assets away from Ethereum, we now have to deal with a separate chain, which means separate liquidity, etc. And then we have to use slow bridges, which eventually become centralized. And the reason why these bridges can be slow is because if you're bridging from one chain to another, let's say from rollup 1 to rollup 2, rollup 1 first submits this transaction. It goes through the entire transaction lifecycle. Eventually, the transaction ends up in L1. but the transaction we have to wait until that transaction is final on L1 before L2 can say the transaction is final. And then when the other rollup is looking to check the status of the transaction that originated on a whole separate network, a separate rollup, it checks the L1 chain, which is Ethereum, to see that, okay, that transaction is final, and then it can perform some work on its chain. So that's why you can understand why it takes a while for bridges that are not centralized, especially, to bridge your assets across, because they want to make sure that that blockchain status final is not going to change, because we don't want to give someone assets that actually they will never get because for some reason the state changed. So if we were to propose a shared sequencer, this is a concept you may have been hearing about as well. We will have something that is being shared, and the thing that's being shared is the ability to select and order these transactions. So in the shared sequencer model, we will see that multiple rollups will be able to submit their transactions to this shared sequencer, and this shared sequencer is now doing the sequencing for multiple rollups at the same time, which means when it gives a pre-confirmation, that pre-confirmation could actually say, well, you know what, this transaction is definitely going to be included in rollup 1, let's say Optimism, and is also going to be included in Arbitrum. And the fact that we can see that within the shared sequencer, then we have this pre-confirmation that gives us an idea that these two transactions will be completed on both rollups, and therefore we can get some interoperability benefits from this. And this is more attractive than a centralized sequencer as well, because normally shared sequencers use a decentralized network, which means we can trust these pre-confirmations because there is some level of consensus that would have had to happen for them to give that pre-confirmation, because a shared sequencer network tends to be decentralized as well. But the issue with using shared sequencers, because if you know about Espresso has been promoting the idea of a decentralized shared sequencer. After speaking to over 40 layer 2s and layer 3s, we realized that a lot of them have an issue with being able to give up the sovereignty of doing self-sequencing. And also rollups make money from sequencers as well. There's no secret about that. So we had to come up with a new model. So the new model that we are presenting still introduces a shared sequencer network. However, we're having a different approach, which is the Espresso Marketplace. So in the Espresso Marketplace, rollups can sell sequencing rights to what we're calling sequencers or proposers. So it's a two-sided marketplace. On one side, we have the layer 2s. On the other side, we have the sequencers or proposers. And they are responsible. So the rollup, they will say, okay, I'm going to set a reserve price. And if you are able to match my reserve price in your bid, I will allow you to sequence for my chain and some future time slot. And the sequencers can say, okay, I would like to sequence for Arbitrum, Optimism at Optimism at the same time. It proposes a bid. There's an auction that takes place. And once it meets the reserve price for both of these rollups, it's able to do shared sequencing for both of these rollups at the same time. So the benefits of integrating with the Espresso Marketplace is, one, there is now a new value capture and creation for layer 2s, because we constantly are going to have these sequencers and proposers who are bidding to sequence for these chains. And once they are sequencing for these chains, they're paying a fee, and that fee can go to the layer 2. Secondly, sovereignty, which is the most, critical part about the Espresso Marketplace, is the fact that you can choose as a layer 2 when you would like to have your block sequenced by an external sequencer. So you can accomplish such as like maybe a combination between sequencing for yourself and using external sequencers, or 100% sequencing for yourself, or 100% having external sequencers sequence for you, because you set a reserve price. And let's say you set that reserve price to 0. That means any bid, would be able to be successful once they choose to sequence for your chain. And if you set it too high, then no bid probably would be able to win and sequence for your chain. And if you set it at a price that makes sense to you, based on, let's say, what revenue you have been earning from your sequencer in the past, and that way, external proposers can sequence for your block, and you can achieve things like having interoperability or increased interoperability amongst not only layer 2 chains, but also layer 1 chains. Because another thing that I actually did not mention is the fact that we have this two-sided marketplace, and the sequencers that are responsible for bidding, it can be LE1 validators as well, which can decide to, do things like restaking via eigenlayer to be able to participate in this marketplace as well, which means you will get the interoperability across layer 1 and layer 2, because the pre-confirmation can include a block from both layer, or a transaction from both layer 1 and layer 2. And also, like I mentioned, it's still going to be a shared decentralized sequencer network that these nodes are running, because they will be running our software called Hotshot, which is our consensus network. And we also have this concept of fast finality. This is another term that is even more recent. And fast finality is actually related to pre-confirmations. And it's the idea that the pre-confirmation will be fast, but it's not actually finality. So it's a bit confusing. And by the way, the pre-confirmations term as well, I think is getting a lot more popular because I saw that Nethermind recently posted a job for a pre-confirmations engineer. So it's definitely an interesting space to start looking into. I was so shocked when I saw that, I think last week. Espresso's fast finality gadget, which enables fast bridging. And I think developers as well will want to integrate with rollups that use the Espresso marketplace so they can take advantage of this enhanced interoperability and defragmented liquidity. So you can follow us on Twitter, Espresso Systems. My name is Alicia Tech. You can follow me there. Bezabel, she's the head of partnerships. And if you'd like to speak to other engineers within the space as well, you can definitely reach out and I can give you their Twitter or Telegram. Thank you.
Amazing. Thank you so much, Alicia. It was, as Pael said in the chat, very well explained. I really like the design of the presentation as well, the espresso tones.
Rocking my espresso t-shirt right now.
I'm rocking the Cartesi one.
I love it.
We should exchange t-shirts on. Are you going to be on Belgium? I want an espresso shirt.
I'm not. I'm missing it. But you should be able to get an espresso t-shirt there.
I'll definitely look for one. So do you have any do you take questions, Alicia? Or
sure, if you guys have questions, yeah.
Anyone has any questions on the chat?
And there are lots of hack MDR as well. Down to a cappuccino now. Love it. Thanks so much for listening, everyone.
Thank you for
coming. And good luck with the hackathon.
Thank you. All right, see you around.
See you.
All right, that was super cool. Espresso is such a cool project. You'll see them. They have a lot of presentations online. They are also on every event, and they're actually solving a very big problem of the industry, right? Because right now, rollups they mostly have their own centralized sequencer, and that's a great source of criticism because they gain a lot of stuff like censorship power and stuff like that. So I really like Espresso. Every time I interact with someone on their team, they're always nice. Yeah, football teams. All right, now we're supposed to have Omrak from Automora from Polygon ID. Are you around? Let me shoot him a message. Yeah, he gave me a confirmation yesterday, so he should be around. All right, let's jump into the dev advocacy unit then.
Hey, that's me in this case.
Oh, nice.
Hi. Right. I don't have a Cartesi t-shirt with me, but I do have my Cartesi hoodie.
That's a beautiful one.
All right.
So you have stage presence enough. I'll just leave you to it.
Oh, don't interact with me. Interact with me. Stay here. Okay. So let me just share my screen real quick. Okay, go live. Can you see it? I don't know if you can see it. Okay, yeah, probably. Yeah. All right. So let's talk a little bit about Cartesi and then show you guys some cool resources that I think can be really useful in this hackathon experiment week as a whole, right? So the first thing I gotta say actually is I'm very sorry because I'm gonna totally be winning. I got Carsten and Shiani on my team. So sorry guys, rethinking that. Anyway, what is Cartesi? So I like to think of Cartesi always as an execution layer, okay? And that means it's pretty simple in the concept, which is we get a state, we get an input, and you can actually process anything you want right there. So you can generate your own outputs, you can run your code, and it's simple enough, right? It should be. But the execution layer by itself is just the engine that moves everything. It has some other components to interact with. And as Felipe said, we really like ideas and projects with interoperability and integration with other protocols. So give that a think, give that a thought, and always check the column of innovation, because you can see what Cartesi can provide with you in tandem with other structures and other applications and protocols. And think about what you want to build. Here you have some really cool ideas by default. So what's the Cartesi machine, which is this execution layer we talk about so much, right? Cartesi machine is this, for those who doesn't know, it's this RISC-V emulator, which has Linux running on it. So you can pretty much do everything that Linux allows you to do. So it's like the computer that you use every day. I totally stole this sentence from Coutinho. I don't know if he stole it from someone else, but I'm always using it. Oh, the pictures also, credit to him. All right, so one of the benefits that this brings is the EVM tooling is kind of limited, right? When we talk about blockchain development. And I like to compare it to a plier because it's one of the coolest and best tools out there. It's probably my favorite. And you can do a lot of it. You can pull things, you can even like nail to the wall with a plier. It's just not efficient. There's more efficient things, and we've been building them for a long while now. And that's what Cartesi allows you to do, right? With a plier, you can cut things, you can do whatever, but there are more specialized tools for everything, and Cartesi allows you to use all of that. So think about the tooling that you're using. Think about what you're bringing in this experiment week, because this is very interesting. It's very helpful. We can use OpenCV, scikit-learn, SQLite, Redis. We have many examples with all of those tools. You can code on Python, on JavaScript, on Go, which is always trying to run. Go for come back here, please. Thank you. Yes, Rest is here. He's your friend. No, he's your friend. Stay. Okay, good. Nice one. So how does the Cartesi infrastructure work as a whole? I put Ethereum right here, but Ethereum is just an example. Just remember how it operates. You just send a transaction to the underlying chain, to the base layer that you're going to be using. And once you send this transaction, it's triggered some function inside your Cartesi node, which brings the input there. It operates, it settles in the layer one, and you can inspect the state directly from the node. You don't need to go through the blockchain for that. You can even integrate it with other protocols. So let's say you have a very good data availability layer with a sequencer integrated, and you can send a transaction, perform a block commitment to the settlement layer that you want, while the input reaches Cartesi. Cartesi settles there, and you can finally read the state as usual, right? So I just wanted to illustrate this to show you a little bit and remind everyone what Cartesi is all about, and maybe this can give you guys some inspiration in the whole building process. So let's talk about resources a little bit, which you can and should use for this hackathon, right? The first thing is our docs. For those who haven't accessed it for a while or never accessed it, yes, use it and give feedback. Thank you, Felipe. We just updated to the version 1.3 not long ago, and it's a really good version. I'm really happy using it every day and presenting things on it. Even our Udemy course, which I'm going to talk about later, was recorded using it. So here you have access to backend APIs. You can understand the kinds of outputs that the Cartesi machine generates that you will be using on this hackathon for sure. Give it a good look at the overview session, get a good grasp of what it does. And then from development, we do have some tutorials, since from installation up to how to create your first apps and asset handling, which is very important, how to retrieve outputs. We do have a deployment guide and tutorials like how to build a calculator dApp, integrating machine learning with Cartesi, building wallet dApps and with JavaScript, Python, and we have more examples. if you need inspiration, you should go to rolluplab.io. I'm sharing all these links later here in the chat after I'm done talking. Sorry if I talk too much. I really like the sound of my own voice. This was pointed to me earlier today. Thank you, Shani, by the way. Anyways, we do have all kinds of applications and tooling here. High-level frameworks like Romulet. We have games like Bubble Wars, random tools like dRand, so you can use randomness in your app, creative apps like the drawing app. So lots of things like that. Be sure to access it. Another really interesting and important resource that I would like to point out to you guys is the Mugen Builders repository. Here you can find lots of things. We do have links for the dots that I just showed, video tutorials. We do have a masterclass on Udemy. It's less than 2 hours. So if you're not familiar with Cartesi or some specific topics, you can just go there, give it a look, and have fun while you learn. So about tools that I really want to show you is the Cartesi CLI. It's a very important one. It's the basis of how to build on Cartesi rollups. You're going to be using this for everything. Nonodo, which is a good lightweight development tool. It pretty much emulates the Cartesi CLI, so you don't have to rebuild and restart your Docker apps all the time. You can actually run your app in your environment while you're building for quick testing. It's really good to test inputs mostly. I use it a lot for that and for debugging. So when you reach any kind of problem, any kind of trouble, you can just access it, and it's really helpful. So from high-level frameworks, I really like to point out some here. dRoll is an amazing high-level framework that I'm going to be showing, developed by Danilo. It's on TypeScript, and it does have here its basic documentation. And just as a cheat, Danilo, don't kill me for showing this, but Michael just did a PR. So if you want a comprehensive reference guide, it's still to be approved, but you do have a comprehensive reference guide to dRoll right here. Give it a check in the PR as well. So we do have Romulet for Go and Python Cartesi for Python, of course. Cartesi TS SQLite is a cool project example that Duim did for us, which is in one of our seed grants, which is a template for TypeScript plus SQLite. So you can almost consider it a level framework as well. Okay, besides that, we do have some applications here like Cartesi Wallet and Python Wallet, which are wallets already implemented in JavaScript and Python. If you don't want to use a high-level framework, you want to use the basic templates, you can simply add them to your project, and it's faster if you want to use the general templates. I really like using, personally, both the Cartesi Wallet and the dRoll wallet in my projects. So giving a look at another really important resource is the prototype dev, prototype with a 3 in the end, /dev, which is the old prototype unit resource. They do have some very important tools in here. And if you are actually if you're developing for front end, they do have 2 tools that I really like to highlight and point out. Most people love developing on React, right? So there is this template for React that you can just plug and play to your project and snippet some parts of it and add whatever you want. I do have it running here. It's built with Yarn. So as you can see, it's really simple and minimalistic, and you can just import and copy the snippets that you need for your project and personalize it, customize it however you want. So I know for a fact that Felipe, you yourself, your group used it on Mibu, on If Denver, right? So for example, if I want to perform a deposit in here, I can just deposit Ether, and it's really easy to integrate to your project, right? Another one very good tool for front end, because this is something that people struggle a lot in general, so I really want to reinforce, is Cartesi Client, which is an NPM package that you can, it's not packaged on NPM, but you can install it with NPM link, right? And it's really easy to use. You can actually query vouchers and notices, reports. You can send transactions. You can inspect states. It's very good. And if you are more familiar with the Web3 way of developing, give it a look to Tikua's project, which is more leaned towards the way that you develop front end on Web3. So you basically create an API and access this API as if it was an Ethereum app. That said, it does integrate seamless with the role by default, and you can totally adapt it to your own preferences, right? Now, last thing I want to talk about, and this is something that pops up a lot, is randomness on chain. There are two ways that we interact with randomness. So the simple way is by using the commit reveal strategy. Every part commits something, and then everyone reveals, and then you generate randomness based on the seed that everyone's revealing. So an example of commit reveal practice that we have is the Arena Mayhem. It's a little game. Oh, you stopped hearing me? Is audio not working?
No, I can still hear you.
Okay,
yeah.
Cool. So one example is the Arena Mayhem, which has a commit deploy strategy, which you can totally use. It's implemented on Python. And the best way to do it, in my opinion, as I mentioned before, is the DRAN tooling, which Fabio kindly recorded 2 videos explaining exactly how it works. So you can take that and implement to your app. And one last thing, if you really want to build machine learning applications, I highly recommend checking out this resource here. It's a tutorial written by Marcus from the Developer Advocacy Unit of how to do machine to code generation and run your applications with machine learning without having to cross-compile lots of things. So yeah, that's it. I know this took a long while. It was more than the 10 minutes that I promised, but I hope it was useful and you can get inspired and build some very cool things for this hackathon right here.
Nice, thanks, João. It's a lot of resources, huh?
Yeah.
Soon it's gonna be hard to go over them in a single presentation.
Oh man, it's getting hard.
Yeah. So I think that's it. We don't have anyone else to present. So if anyone has any questions, just feel free to reach out. Let's have fun. And yeah.
Yeah, I just want to add to that something that I didn't comment. My bad. Developer Advocacy Unit is always doing developer relations. Any need that you have, any queries or doubts you have, you can just reach to us. We're helping on the journey and give us feedback on everything that you find complicated or complex during the whole development journey.
Yeah, it's very important. It's a week for feedback and introspection and insights and fun as well. But keep in mind that it's a time for us to judge. Try to imagine yourself as someone that never seen Cartesi before and trying to use Cartesi for the first time and write feedback on that. I'll post on the chat the recap of the previous experiment week so you guys can remember how many cool applications were created. Some of them are still around, some of them are being used on workshops. Feel free to grab one of them and use it as your own experiment week, like progress it, take it forward. And yeah, let's build whatever. All right, I'm gonna be signing off if anyone has anything else to say. Yeah, Guilherme, great experiment week to everyone. Let's do it.